Alright, this is still in section 9.2 on the second page of the handout at the top. It talks about determine the minimum sample size needed for a specified margin of error. This is like if the boss gives you restrictions without anything else to go on, how you figure out your sample size. And so this is again related to the confidence interval calculation, where we wrote down in class x bar plus or minus the critical value times the standard deviation over the square root of the sample size. And the margin of error part is the second part, the plus or minus. That is your margin of error. So the margin of error for means is the critical value t star times s over the square root of n. T star times s over the square root of n, and I like to put this part in parentheses so I can see it better. The problem is we don't have a sample size. If we don't have a sample size, we don't have degrees of freedom, and there's no way to look up t star without degrees of freedom. So, since we don't know the sample size, we can't look up the t value. So instead of t star, we use z critical values again like we did in section 9.1. So we use z star times s over the square root of n, and again it might be helpful to put that part in parentheses. So we're going to use that for example 5. If we want to estimate the miles per gallon of a 2007 Ford Taurus with 95% confidence within a 5.5 miles per gallon margin of error, what is the minimum sample size needed? The only thing we need from the data is the standard deviation, which we calculated to be, let's see what it was, 3.208. So we need that from the data from previously. Otherwise, they'll give you the standard deviation, which we'll see in the extra example. So we have our setup. E equals z star times the standard deviation over the square root of the sample size. So our margin of error is 0.5. The critical value for 95% confidence is 1.96, going back to section 9.1, times the standard deviation, which is it's usually just given to you, 3.208 over the square root of n, and n is the part we don't know. So again, it takes some algebra here, and we all do algebra a little bit differently, but the steps I take is that I divide by the critical value. So I divide both sides by 1.96, and you end up getting a really nasty decimal. And I try to keep it all stored in the calculator so I don't lose anything. 0.5 divided by 1.96. There's our big crazy decimal, 0.25510200408. You don't have to write the whole thing down, but keep it stored in the calculator. And that equals 3.208 over the square root of n. So that's step 1. Step 2 can be done several different ways. You can put that crazy decimal over 1 and cross multiply. What I do is I take I divide the standard deviation by the answer. So I do that in the calculator. I take the standard deviation, which we're given, 3.208, and I divide, and the way to do this is to hit second, and then the negative button says answer right above it, ANS, so second, negative, and what that does is it stores the exact answer in there for you. So 3.208 was my standard deviation, divided by, and then second, negative. You see what it says A and S, that means answer. So when you do that, again, you get a crazy decimal. So you have 12.57536 equals the square root of n. So however you get there, that's where you should get. And then the next step is to square it. And again, if you just push x squared, it pulls the answer in there for you. You just push squared, enter. There it is, 158.14. So we've squared both sides. Now, no matter what we're talking about, we have to round up. We need that 0.14, and we have to round all the way up to 159. And this was talking about Ford Tauruses, so we need 159 Ford Tauruses in our sample. At least that many. You can always have more. So 159 is the answer.